Okay, so today we're going to start on the alternating series test. Okay, so those are the ones when you have your -1 to the nth power or -1 to the n plus 1 power. This is the test you could use for that one. Okay, so if we let our a sub n be a positive series. Okay, the alternating series the sum from n equals 1 to infinity of -1 to the nth power. Oops, clean up that n a little bit. Or sum from n equals 1 to infinity of -1 to the n plus 1 of a sub n converge if the following conditions are met. Okay, so first, the limit of a sub n has to equal 0. Okay, and second, it has to be decreasing. So a of n sub 1, a sub n plus 1 is less than or equal to a sub n for all of n, which is just a fancy way of saying, well, not really decreasing, more like non-increasing. All right, so let's say, for example,
does that say n plus 1 for the other one?
Yep, this is n plus 1 and n.
Okay. So as n grows,
Yep.
number.
Yep. So as n is getting bigger, the one in front is always going to be in front of the previous one. I mean, below the previous one.
Right.
Okay.
Would the first sum start from 0?
What do you mean first sum start from 0? Oh, it could start from 0 or 1.
Okay.
So 1 is just you're mainly focusing on the n and the n plus 1 for -1. All right, so let's say, for example, if you want to determine, should I do it? Yeah, I'll do a separate page so I'm not squeezing everything on the bottom of this one. All right, anyone still writing?
The a n plus 1 is less than...
Yep, less than or equal to a sub n.
n plus 1 or n minus 1?
N plus 1.
Okay.
I think that's just... Yep, n plus 1. Uh-oh. A little flicker.
You need to freeze it?
Yep, I just did that one.
Okay.
So it could stay on the screen a little longer.
Okay.
All right, so let's say if you wanted to determine the convergence or divergence of the sum from n equals 1 to infinity of -1 to the n plus 1 times 1 over n. Okay, so the first thing we're going to do is find the limit of your a sub n. And in this case, your a sub n is actually equal to 1 over n. So we're kind of just ignoring the -1. Okay, so for your first step, the limit, or you can say 1 over n or 1 over x if you want to. 1 over x as x approaches infinity is equal to 0. Okay, remember, the limit is equal to 0, but the series is not. The series diverges. Okay. Now for a of n plus 1 is less than or equal to a sub n, that just means that instead of 1 over n, you have 1 over n plus 1 is less than or equal to 1 over n. For all n greater than or equal to 1. Which is true. Because if you have n equals 1, you'll have 1/2 is less than 1, n equals 2, 1/3 is less than 1/2, and so forth and so on and so on. So it passed the first condition and the second condition. Okay. So both conditions are met, so that means it converges. So by the alternating series test, sum from n equals 1 to infinity of -1 to the n plus 1 times 1 over n converges. All right. So any questions on that one? Now, it doesn't say what it converges to. It just tells you that it converges.
Is the only test that we know so far that tells us what it converges to the integral test?
Yep, the integral test will tell you exactly what it converges to. The rest of these are just telling you whether it converges or diverges. Yes.
You couldn't apply the P-series test to that, could you?
You could if it was just 1 over n,
Right.
but when you have the -1 in front of it, you can't use the p-series test.
Okay.
But yep, just the 1 over n itself would diverge.
So there's no way to split that out?
Not really, because when this n changes, this n changes. So,
Okay.
right. I don't know, just those little subtle details change it. All right. Any other questions? All right. Okay, so did I skip one? Oh, there we go. Okay, so let's say, for example, we have the sum n equals 1 to infinity, -1 to the n plus 1 power times 11n over 8n plus 6 using the alternating series. Okay, so the first thing we have to do, since we know that our a sub n is equal to 11n over 8n plus 6, let's find the limit. Okay, so the limit as n approaches infinity of 11n over 8n plus 6, remember that would give you infinity over infinity. Uh-oh. Didn't mean to make it that wide. Which is an indeterminate form, so you can use L'Hopital's rule. Or you can just divide every term by n, you can do that also. But every once in a while, just want to use L'Hopital's rule just for the heck of it. Okay, so you have the derivative, limit, why am I writing that? There we go. As n approaches infinity, the derivative of 11 times n is just 11. Derivative of 8n plus 6 is 8. So your limit is 11 over 8, which is not equal to 0. So right there we can stop because we already know if the limit doesn't equal 0, it's going to diverge. I mean, not diverge, you can't use it because in order to use it, it has to pass both conditions. But we can also go back and use the test for divergence, which means that if it doesn't equal 0, it diverges. Okay, so the alternating series test cannot be applied since the limit does not equal 0. So if we use the test for divergence, which says that if the limit doesn't equal 0, then it diverges. So the limit of 11n over 8n plus 6 as n approaches infinity does not equal 0, so it diverges. Yes.
And what was the second step of the alternating series test look like on that?
Oh, you mean the second step on this? Oh, the a of n plus 1? So that would be, if it was convergent,
Right.
you would just replace all of your n's with n plus 1 and see if it would be increasing. So let's say if you were to use the second step, that would be 11 times n plus 1 over 8 times n plus 1 plus 6. It's less than or equal to 11n over 8n plus 6. Okay, which would be 11n plus 11 over 8n plus 8 plus 8 is 14, less than or equal to 11n over 8n plus 6. And with that one, since the denominator is bigger here, it looks like this one would be smaller.
You could factor some stuff
Yeah.
out here.
Yeah, you could factor out. Nope, hold on. Nope. Yeah, you could factor. Yeah. You could factor out 11, then divide both sides by 11. So you have n plus 1 over 8n plus 14. Factor out a 2, then multiply both sides by 2 to cancel out. Or you could even cross multiply to simplify that one.
If you cross multiply, then how the heck are you telling which is bigger or smaller in this case?
Well, if you just kind of leave that blank, you could see what value they'd be equal 4. So with that one, oh no, that'll just make it more complicated.
That's
Forget
what
that
I
part.
mean.
Right, that's what I'm asking. I think, like,
Yeah, like,
Yeah.
I'm trying to figure out if the
Yep, so
like
with
sign
this one,
flips it all too.
oh no, only if you divide by or multiply by a negative number. That's the only time you have to flip the sign.
I think
But-
factoring out the 11 and then like on top and then.
Yep, that's
dividing
probably
by
the
bottom.
quickest way to do that one. So if you factor out 11, 11n plus 1, and you could factor out 2 here, might as well. 2 times 4n plus 7. And this, if you have 11n, factor of 2 times 4n plus 3. Multiply both sides by 2. Those cancel out. Divide both sides by 11. Those cancel out. So with this one,
No, it is bigger on the left.
yep, because this denominator would be just a little bit bigger, but that really wouldn't matter if n was, yeah, it would be always be bigger. So this would be n plus 1, which,
But it's not equal. to
yeah, but it wouldn't be equal to. So this one, it would still probably pass the second one.
It
I'll
would
probably
still
plug
pass
in.
Considering that
Hmm?
n plus 1, but it's 4 and what is that, plus 7?
Yes.
In comparison to n, 4n plus 3, there's a
Mhm.
4 deficit there in comparison to the...
And it's such a small difference only because if you have, let's say, 1,000, you have 1,001 over 4,007 if you go all the way up to 1,000. Then you have 1,000 out of 4,003. Here your denominator is a little bit bigger. And that difference of 1 won't counteract that denominator being bigger. So when that denominator is bigger, it's actually a smaller number.
Yeah.
So is that the easiest way to just plug in a number for n?
Oh no, that was just kind of an example. For that one, it's hard because they're so close, it's hard to really see it. So I just plug in like a big number and kind of compare it that
Well,
way.
That's what I'm asking. Is
Oh,
that
yeah.
the fastest way?
Oh yeah, just to
Like,
kind of
the
get
11 to
an
the-
idea, yeah.
Okay.
Unless you can look at it and say, okay, this is always going to be a bigger
Right.
denominator than that one. But with that one, they were so close, it was one of those, I'll just plug one in and see how it looks.
Just a question about the whole alternating series.
Mm-hmm.
We know that -1 to the nth power times any an would converge with those two things, along with n plus 1 for the power as well.
Mhm.
But could that be n plus any constant that is an integer, so to speak?
N plus any constant.
So
Well, they would actually kinda
Could it be like
repeat.
n plus 8 as well and still technically?
Yeah, but
converge?
that one would kind of repeat because if you have, oh, let me kind of cross that out so no one's confused there.
I know, just making certain that
Alright.
there's not some special case here.
Oh no, because if you have, let's say, -1 to the nth power, when n is equal to 0, you'll have 1. When n is equal to 1, you'll have -1. When n is equal to 2, you'll have 1, and so on like that. But if you have -1 to the n plus 1, when n is equal to 0, that'll be -1 to the first power. So you have -1, then you'll have 1 and -1 and like that.
So it's just, okay, I see.
Yep, so if you
it's just a
have,
shift.
yep, it's just a shift. So if you have -1 to the n plus, let's say 5, that's just going to be -1 when you plug in n equals 0, -1 to an odd value.
Okay.
So it'll just be -1.
And this should only work
Yeah.
for integers, so to speak.
Oh yeah, just integers. Well, actually, -1 to the any power. I mean,
Yeah, that's
1
right.
to the any power is just going to be 1. But -1, it would mostly use integers, especially when you're dealing with summation.
Well, that and also if you get a. Like
'Cause
a
the matrix only
fraction with
goes
a
up by
negative
integers.
number, you're starting to get into imaginary numbers, right?
It depends on which one it is. If you have an odd index, then your answer would just be -1.
Yeah,
But if you have
but
an
if it's
even
an even
index,
index.
then it'll be a imaginary number. All right, that make sense?
Yeah, it does. Thank
Okay,
you.
no problem. All right.
Is that saying like if you take the cube root of -1, it'd still be -1?
Yeah.
Imaginary.
Yep, so as long as it's odd, it'll still be -1. All right, any other questions on this one?
Nope.
Good, you have no more questions, he said so.
You're all doomed if you have a question.
All right, so let's say, for example, n equals 1 to infinity of -1 to the nth power over 6n to the 4th. Using the alternating series. Okay, so your first step, well, first you need to know if we bring out that -1, your a sub n is just 1 over 6n to the 4th. Okay, so your first step, you want to find the limit of your a sub n, 1 over 6n to the 4th, as n approaches infinity. Okay. Well, you can factor out the 1/6. 1 over n to the 4th is 0. Okay, so that one passes. Then your second step, a of n plus 1 has to be less than or equal to a sub n. Okay, so that means that 1 over 6 times n plus 1 to the 4th power is less than or equal to 1 over n to the 4th power. Well, 6 times n to the 4th power. Which is true because this denominator will always be smaller than larger than this one. So that means the left side will always be smaller than the right side. Okay, so this is actually true. Since the left denominator will always be larger than the right. Clean that up a little more. Okay, so since it met both conditions, you know it converges. Both conditions are met. So the sum from n equals 1 to infinity of -1 to the n over 6n to the 4th converges. Oops. All right. So does anyone have any questions, Greg? No one has any questions? Greg said so. Yeah.
So after we prove it's convergent on the test, are we going to have to use another method to find what it converges to?
Oh no, if it asked for what it converges to, then you would have to use another method. But if the question just says there's a converge or diverge, if you wanted to, you could use this one, even though this isn't going to be on the test. But if you want to use this one or the root test or any of the other ones we're going to go for today, you can.
Does the integral test work for every series in determining whether it converges to a certain point? Or are there cases where it could fail technically at actually figuring out what something converges to if it converges?
If you can integrate it, it will work.
Okay.
Yeah. Only if you have one that you just couldn't possibly integrate, which you're not going to have any. Oh, put that one there. All right. Any other questions on this one? Okay. Okay, so now we're going to go into absolute and conditional convergence. Okay. Now with absolute convergence, states that if the series, the sum of the absolute value of a sub n, and that could be from n equals 0, n equals 1, I'll just put n equals anything, converges, then the series itself converges. Okay. Well, I guess you could say converges absolutely. So make sure. But we'll separate that completely. So at absolute convergence, now your conditional convergence is the summation from a to n, or the series, is, let me write this so it's a little bit clearer. Converges, but the absolute value of that series diverges. within the series is conditionally convergent. Okay. So in other words, the first thing you want to do is test the absolute value of the series. If it converges, you know the series itself converges absolutely. But if the absolute value of the series diverge, but then when you remove the absolute value and the series converges, then it converges, conditionally. I was about to say continuously. All right, so let's do a quick example. Oh, anyone's still writing? I'll leave that up there for a few seconds.
Very good.
Oh, all right. Hmm?
I'm sorry.
Oh, no problem.
So if the absolute value of a series converges,
Mhm.
then by definition, the non-absolute value must converge,
Yep.
but not the other way around.
Yeah. Well, if the absolute value diverges, but the regular a sub n converges, then it converges. Conditionally.
Okay, so you can't tell anything from the regular, but you can tell from the absolute.
Yeah.
All right.
That's pretty much like the guideline. All right. Oh, anyone still writing? No. Okay. So let's say, for example, if we want to determine if actually we did this one already, but we can do it again. And we'll be able to tell n plus 1 over n is convergent or divergent. And if it's convergent, classify if it's absolutely or conditionally. Oh, this is getting ready to